Hello friends, in this video I am going to explain about the visual and statistical methods of checking the normality assumption for the sample dataset using SPSS. Checking of normality assumption is necessary to decide the approach to be used for testing of hypothesis. Based on the results of normality check, you may use non-parametric or parametric tests of hypothesis. In the normality check, we test the assumption whether the sample data comes from normally distributed population or not. So, let us first understand the theory and the interpretation of both the methods. Visual methods of normality check include histogram, boxplot, and QQ plots. The histogram is a great way to quickly visualize the distribution of a single variable. It gives us the frequency of occurrence per value in the dataset, which is what distributions are about. If the sample observations fit in the normal distribution curve, then we can assume that sample data comes from normally distributed population. If it does not, then it is a violation of normality assumption. Boxplot, also known as box and whisker plot, is a 5-number summary visual method of checking the normality assumption. It shows the minimum, maximum, and first quartile, third quartile, and in between the median, which is also known as the second quartile. The difference between third quartile and first quartile is the IQR or interquartile range. The numbers beyond the minimum and maximum limit are the outliers. If the area towards the right hand side of the median is more than the left hand side of it, then the distribution is said to be positively skewed. Otherwise, it is negatively skewed. The third visual method is QQ plot. QQ plot stands for quantile versus quantile plot. By a quantile, we mean the percent of points below the given reference value. Thus, QQ plot compares the actual quantities of the variable against the theoretical quantities represented by 45-degree reference line. If the dataset comes from a normally distributed population, all the observations should lie on the reference line. If it does not, then the dataset does not come from the normally distributed population. Visual methods of checking the normality are subjective methods and can only be used for quick visualization of the dataset. Therefore, statistical tests of checking the normality are mostly preferred. There are two statistical methods of checking the normality. Number 1, KS test. If the observed data perfectly follows a normal distribution, the value of the KS test statistics will be 0. And the p-value used to decide whether data comes from normally distributed population or not. If p-value of the KS test is greater than 0.05, we assume a normal distribution. Otherwise, we do not assume a normal distribution. This method of checking the normality has certain limitations. It requires large number of observations to reject the null hypothesis. It is also sensitive to outliers. On the other hand, it can be used for other type of distributions as well. Best method of testing the normality is Shapiro-Wilk test, and it is most powerful test when testing for a normal distribution. It has been developed specifically for the normal distribution. It cannot be used for testing against other distributions like, for example, the KS test. If the p-value of the Shapiro-Wilk test is greater than 0.05, we assume a normal distribution. Otherwise, the data does not come from the normally distributed population. The Shapiro-Wilk test can handle a large dataset as well as small dataset to check the normality. Now, let us check the normality assumptions using SPSS. I have a SPSS data file which is taken from the inbuilt sample database of the SPSS. The data file is related to the bank loans. Before checking the normality assumption, you should remember that normality assumption should be checked for interval or ratio scale variable only. By default, the categorical variables like nominal and ordinal variables, they are assumed to be non-normally distributed datasets. Hence, the normality check should be performed for the interval or ratio scale variables. In order to test the normality, click Analyze, go to Descriptive Statistics, Explore, and I want to check the normality assumption for the age variable. So transfer this variable to the dependent list. Click on Statistics, nothing to change. Click on Plot. You make sure that histogram is checked and also the normality plots with tests box is checked. And here display both statistics as well as plots. So make sure that both option is checked. Now click OK and it gives you the summary of the normality check. This is the statistical method summary of normality check. Let us first go with the visual methods of checking the normality. In this histogram, you can add a normal distribution curve by double clicking it, and double clicking in the SPSS graph or table opens up the editor window. So here on this graph you can add a normal distribution curve by clicking on this button and then close it. Close the chart. Here you can see that normal distribution curve is also plotted on the histogram. So data does not fit entirely into the normal distribution curve. That is why we can assume that data is not normally distributed. Another method is the QQ plot. So as per the theory, these observation points should lie on the reference line. If they are not lying on the reference line, it means the data is not normally distributed. So second confirmation of non-normality of data. Third method is box plot. If you want to rotate this box plot, you can rotate it by double clicking it and click on this rotate option. Now you can see that area towards the right hand side of this midline, which is the median, is more than the area towards the left hand side. Hence we can assume that data is not normally distributed and it is positively skewed. As I said, these methods are subjective methods, so we need to confirm the normality check using the statistical method. Now this table shows you the statistical interpretation of normality check. The p-value of KS test is less than 0.05. Hence, we conclude that data is not normally distributed. Shapiro-Wilk test is also confirming the same, that data is not normally distributed. Had the data come from the normally distributed population, the p-value of KS test and Shapiro-Wilk test would have been greater than 0.05. In this case, the values are less than 0.05. Hence, we conclude that dataset does not come from normally distributed population. Thus, we can use non-parametric test of hypothesis to apply with the age variable. So friends, hope you liked the video. For more updates on similar videos, please like, share, subscribe and press the bell icon for the immediate notifications.